Okay, hi everyone. Second video then. So if you're tuned into this one, it means that you are having a bit of trouble with fractions, or you just wanted to learn a bit more about fractions. So again, try and keep this short. I spoke way too long last time, but that was maybe as an introductory. Two sections this time, exercise 2A and 2B. So if you are fine with 2A, then just skip it, move on to 2B, and let's go. So when we're writing as a single fraction, the key thing is we're trying to make the denominator the same. So if you had 2 by 3 plus 1 over 4, okay, and obviously you could just whack that in your calculator, and what would happen? Well, we don't have a calculator for this, and even if we did, the idea is not to use it because we're trying to get the theory right here. How do we put them together? Hopefully you're screaming into your sets that we need to make the denominators the same. So 4 and 3, what's the easiest way to make that denominator the same? Well, you're trying to find the lowest common multiple of each other. So 3, on the bottom, you're going to need to have that as it's going to need to be times by 4. Okay, so on the bottom 3, we need the one on the bottom to be 12, really, don't we? Because 3 and 4 both go into 12. So what we're doing is we're timesing the top by 4, and we're timesing the bottom by 4. And for the second expression, we're timesing the top by 3, so 1 times 3, and the bottom by 3 as well. Now, you're probably aware why you need to do that, but just to reiterate, you have to times the top and bottom by 4 because that way you are timesing it by 1. Because 4 over 4 cancels and makes 1, doesn't it? Just like 3 by 3 cancels and makes 1. So you haven't actually changed the object, you see, because if we set that equal to z, you know, some people, if I was just to times it by 4 on the top and times it by 3 on the bottom, then I haven't actually got what I started with, because z isn't this z equal this, but that's not the same as that, see? So just like with algebra, we have to do exactly the same thing, okay? So we need to make them have a common denominator. So this first one has an x here, but this second one doesn't have an x. So in order to make the second one look like the first one, I need to put an x on the top. It already had an x here, and therefore an x on the top and bottom, sorry. An x on the top and bottom. So this has an x now. So this one has a 5, this one doesn't. So we need to introduce a 5 here, and if we introduce a 5 on the bottom, we need to introduce it on the top, okay? The most important thing there. Now the denominators are the same, I can put them together, okay? Common denominator, just like if you had a half plus 3 by 2, you would say that's the same as 1 plus 3 by 2, so 2, 4 by 2. Exactly the same thing here. Denominators are the same, so therefore I can put them together, and that's simplified as far as that can go. Okay, done. Part B. Again, this bottom one has an x take 1, but this one on the right doesn't. So I need to times by x take 1, times by x take 1. Careful with the brackets, right? You must have brackets, otherwise it doesn't mean what you think it does. This one's missing an x plus 1. So I need to put an x plus 1 on there as well. Okay, now they have a common denominator, so I can put them together. Take 1, x minus 1, x plus 1. Okay, it's not simplified yet. I would need to expand this bracket out. So times in the bracket out. So 2x times x is the same as 2x squared. 2x times 1 is the same as 2x plus x and plus minus 1. X take 1, x plus 1. Nearly there then. So just tidy it up. 3x minus 1, x take 1, x plus 1. And that's simplified. That's now a full fraction together. And just to reiterate that idea then, we can do it with numbers. So again, just stop the tape if I've gone too fast, rewind it. Okay, we can do this with numbers. So this whole BODMAS idea, which one comes first, but the brackets tell me what must come first. If the brackets weren't there, then it would be your BODMAS and the division would have to come first. It would be 4 over 5 divided by 2 over 3 and then added a third. But as there's brackets here, we're going to do these first. So a third plus 4 by 5 can't do it because the denominators aren't the same. So the bottom's going to need a 5 and the top as well. And this side is missing a 3. And now these are the same. So we'll deal with that 2 by 3 in a second. So here we get 5 on the top over 15 plus 12 over 15. Denominators are the same, so we can put them all together. So 15, 5 plus 12, and it's still divided by 2 by 3. 5 plus 12 is 17 over 15. Now this divided by 2 by 3, remember that's the same as like this then, isn't it? So I would always do a big line for when I'm dividing one fraction by another, so I can really see what's happening here. And like we did before, this fraction then flips up, doesn't it? So this is the same as 17 over 15 times, and now it flips over 3 by 2. How do we cancel that down? I would not times 17 by 3 and then 15 by 2. So remember, in fractions, it's the top times the dot and the bottom times the bottom, right? That's going to be really difficult because 3 times 17, well, it's not going to be really difficult, it's just pointless. Can you see that fractions are interchangeable? This is the same as 3 divided by 15 times 17 over 2. And 3 by 15 you can simplify down. So that's the same as a fifth times by 17 over 2. So this is the same as 17 over 10. Okay, next one. So simplifying fractions and solving for x. So the same thing as what we've just done, but this time we've got an equals value here. So part A, can't compare this yet. I need to make the denominators the same. So we could just make the denominators the same. Let's do it. So 2, this is the same as 2 over 1, isn't it? And this doesn't have a 3 on the bottom. So in order to make it the same, we're going to put a 3 on the top and a 3 on the bottom, yeah? And now you know, or you can see that the denominators match, because this is 6 over 3 minus x minus 1 over 3 is 4x. So let's put it together. Now be careful here, because this should be bracketed off, do you see? Because this is the same as 6 minus x minus 1. The whole thing is being subtracted. Lots of mistakes are made there because people aren't putting in the brackets, and therefore they're writing something like 6 minus x minus 1, and it's not, because it's minus x plus 1, do you see? 6 minus x and minus 1 times minus 1 plus 1. So there we go, we get our 4x. So 6 plus 7, 6 plus 1 is 7, 5 over 3 is 4x, and now we're nearly there. So we could times everything by 3, and the 3 will cancel. So if I times the left by 3, okay, then I need to times the right by 3. So 7 is 13x, okay? Now hopefully we're thinking, oh, I could have just times 3 everything by 3 at the start. Yes, you could. Yes, you could. Okay, so why don't we try that approach for number 2? So simplifying fractions, putting them together, doesn't necessarily have to happen if you recognize that you can just times things out. So we'll practice it again though here. So we've got x take 1 over 2. That's missing a 3, isn't it? If we want to make it have the same denominator. So 3, everything times by 3 on the bottom and on the top. Plus, and this one, this right hand one is missing a 2. So 2 times 2x, but if I do it to the top, I've got to do it to the bottom as well. Now the denominator is the same, I can put it together. So that's everything over 6. And 3 times x, 3 times minus 1 is minus 3. Plus 2 times 2x is 4x is 2. So here we get 7x, take 3 on the top, over 6 is 2. And in order to get rid of that 6 on the bottom, we could times both sides by 6. So if I times the left by 6, I need to times the right by 6. And 2 times 6 is 12. So 7x is 15. and therefore divide by 7 to get x is 15/7. Okay, so again, if I'm going quite quick and it's too fast, just rewind and go for it again. Okay, let's just do that last one. Okay, 2x to the minus a half, a bit more challenging this time. So 2x to the minus a half minus 3 root x plus 2 over 4x equals 1 over root x. Okay, let's tidy up this x to the minus a half here. We know that that is the same as root x, don't we? Because it's 1 over x to the half, and x to the half is root x. That's quite helpful. So if we're trying to make the denominators the same on the left, this one has a 4, this one doesn't. So we times the top and bottom by 4, do you see? This one has an x, this one has a root x. So if we want the denominators to be the same, I need to get x on the bottom. So if I times the bottom by root x and the top by root x times root x is going to be x. So on the top, if I clean this up, I've got 8 root x over 4x. And now as the denominator is the same, I can put it together. But remember, there's a whole bracket around here because it's minus everything in here. 3 root x plus 2 is the same as 1 over root x. So this simplifies down to 8 root x minus 3 root x, times that out, and minus 2, 4x, 1 over root x. Okay? Again, let's do the same as what we did last time. So if we times everything by 4x, so if I do that to the left, by the way, so 8 root x take away 3 root x is 5 root x. Take 2, we'll just write that again. Okay, let's do this again. So I've got 4x on the bottom. I want to get rid of it on the left. If I times it at the left by 4x, that will disappear. But if I do it to the left, I have to do it to the right. So I've got 4x times divided by root x. Well, this goes with our indices work. Root x is the same as x to the half. So x divided by x to the half is the same as, again, if you make your numbers on the outside, x to the half, x divided by x to the half is the same as x to the 1, take away a half. So this is root x, you see? And then we can just put all the root x's on one side. So 5 root x take away 4 root x, that's root x. All the numbers without an x in it on the other. And we have now root x equals 2. We want x by itself. So it has been square rooted. We need to square it. Square both sides. And we get x is 4. Okay, how do we do for time? Damn, still too long. Okay.